So without further ado, well, you all know you can. So yeah.
Okay.
For using the voicemail system. Goodbye.
You can all hear me, not? Yes. So first of all, a very, very big thank you and a hug to Patrick and Jason for inviting me. Believe me, it's really an honor to be here at the first. I can hear you. Oh, we have the same problem. I don't know. Right? They cannot hear me.
Maybe just blow into to see. Yeah.
Can you hear me now? Okay. So first of all, thank you everybody for inviting me. It's an honor to be here to open actually the series of seminars you're giving in Lancaster. So and I'm happy to see so many people here. Most of the things I'm going to talk about today is, of course, about the brain. Okay, usually 95%, I would say, of researchers in this specific field, neurolinguistics, bilingualism, are actually coming from a linguistic or psychology background. And there are a few people like myself who come more from a neurological background, because of the other way around. But there's always some moment where we've come together and exchange our opinions and views, and then we collaborate. So it's a really multidisciplinary field. As you have seen, I'm going to talk about the future in the neuroscience of bilingual research. So what should we do in the future, where we should put our efforts into it, and so on. And I want to leave 10 minutes at the end where we can all discuss together what you would actually propose, what should have. Everything fine? Okay. Like proposals from you, what you would like to be discussed, to be studied better in the brain and bilingualism. But before talking about the future, I just want to make a brief overview on the past of the neuroscientific research of bilingualism. And I start with my first slide. The history of neuroscientific research in bilingualism can be dated back in the mid-18th century, when Paul Broca discovered the language organ, the language area in our brain in 1861. In the following years, many researchers have postulated, okay, but what would happen to that area if someone speaks more than one language? And the first proposal actually was a British proposal from Huffling Jackson in 1881, who proposed probably it should be the same area that accommodates another language. Okay, and then this came into disuse. Like 100 years after, we would pull out those suggestions. The first real study on bilingualism and the brain was actually the paper of Peters in 1896 on 6 aphasic patients who recovered their 2 or 3 languages in a different fashion. Okay? And that gave rise to the idea that languages may be stored in different parts of the brain. And this was the predominant philosophy for at least 100 years, up to the event of Neuroimaging. Okay, I would say till up to 1995, we would still see papers who would state that language A is in the right hemisphere, language B is in the left hemisphere, and so on. And this is very provocative, this slide, that each language has its specific place in the brain, which is not correct. Okay, I mean, just all languages, whatever language, even sign language, they are all in the same language, which is brain area in the left hemisphere. Okay, of course, there may be individual exceptions, but those individual exceptions we see also in monolingual speakers. Some of the monolingual speakers, despite being right-handed, have the language area in the right hemisphere. They exist. Exceptions always confirm the rule. But most importantly is as a message that all languages are stored in the same language area of the brain. Functional neuroimaging, the early experiments, this is an experiment from 2002, I guess, reported differences, okay, when speaking one language as compared to the other, okay? Like in this case, group A are Spanish Catalan speakers, group B are Catalan Spanish speakers. Both populations were living by then in Barcelona. And in Barcelona, despite being very proficient in both languages, the language most spoken is Catalan. Okay, this brain activity refers to when you speak your second language. So the Spaniards are speaking Catalan, and the Catalan subjects are speaking Spanish. And the question is, why, despite the same age of acquisition and language proficiency, why do Spaniards activate more when they speak their second language? It is because they are less exposed to their second language. Okay, so when you're less exposed to your second language, you need more auxiliary activity from other functions like executive functions, attention, memory, and so on. And this explains different brain activity, like larger brain activity. Okay. If all factors would be the same, like exposure, age of acquisition, proficiency, probably brain activity would be the same for two languages. And here I must make a small break on some specific language features. We also see differences, for instance, when we speak Chinese and English, okay, especially for tasks that include reading, okay, because you have also to interpret some specific features of each language. European alphabets are phonologically, so they usually are on the left side of the brain. If you read Chinese, it uses much more semantic ways. Okay, it's not a real alphabet like letter by letter alphabet in European languages, but you have to know the semantics of the script you see. And semantic in our brain is much more widespread bilaterally. So if we see a Chinese-English bilingual doing a reading task in the scanner, and there's activation on the right hemisphere for Chinese reading, I cannot say that Chinese is stored in the right hemisphere. I only can say that Chinese reading relies also on visual spatial features, which our alphabet has not. So that's something specific, okay? But globally, we can calmly state that languages are always in the left hemisphere and are activated to the same degree if all parameters, age of acquisition, proficiency, exposure, are the same, okay? If the proficiency is lower in one language, you activate more, okay? If the exposure is less, you activate more in your brain, outside of typical language areas, okay? Another thing that we have studied, I would say 15, 20 years ago, we started studying is language control. Because if a bilingual can lose one language, okay, because of a brain damage, while still being able to speak the other language, and it's not a problem of localization in the brain, then there must be something that is not working in the brain. So how is it possible to speak one language and the other? And there are even much more interesting features of bilingual aphasia, for which, for instance, a bilingual is able to speak for 1 or 2 weeks in one language and then not anymore again, speaks the other language, or features like understanding one language but not being able to speak that language, while being able to speak the other language, but that language I don't understand. Okay, so it must be a problem of control, okay, that we are not able to control equally our languages. And Michel Paradis, who was probably the most prominent researcher in the field of bilingual aphasia, made a point of this. Is that usually in the case of bilingual aphasia, the language areas are not completely destroyed, unless there's a huge lesion which knocks out the entire left hemisphere. But it's a problem that that lesion knocks out the device we have in our brain to control our languages. Okay, and this is the reason why we came up together with David Green. We came up with this inhibitory control for bilingual language production. Okay, whenever I want to speak a language, I have to inhibit the other, and so on. Okay, in the first years, like from 2005 to 2010, we were pretty much criticized for this, especially from psycholinguists. Okay, they were always asking us the same question: why is it inhibition? It can go also, the same mechanism can also work just through activation. Okay, and I would say technically or conceptually that would be possible, but one has to interpret also the physiology of the human brain. 33% of neurons in our brain have only one function: inhibition. Okay, so 33%, 1/3 of our brain cells of neurons are only inhibitory neurons. Okay, and we know since a long time that inhibition speeds up selection. Okay, we put pretty much emphasis on figuring out what is the language control network in the bilingual brain. Okay, and I will show you some of the models, and especially the AEC-H model, which Kelly gently wants to illustrate to us, which you can see here. Okay, and it's the model per se is based on neurobiological evidence. Okay, when we created the model, by that time there were already many studies on neuroimaging and bilingualism. So we had pretty much evidence, and we of course combined also evidence from the more clinical field, from aphasics, bilingual aphasics. The model per se explains us that there are different pathways, okay, and they're differently engaged based on the context in which a bilingual is, okay, and there may be different contexts. Context could be a bilingual is placed the whole time in a monolingual context, despite being very proficient, whatever, but is used to speak only one language. Then there's a context which is a bilingual context where both languages are frequently spoken. And the third context would be a dense code switching context, okay? Like those countries where it's very common to mix both languages. I usually make the example of, for instance, the Philippines. If you go to an ATM, you have three options: Tagalog, which is Filipino, English, and Taglish. Okay, and actually, if you're in the Philippines, you get used to it, that people that just switch from Tagalog to English as it would be normal. And this frequent switching, as you better know than me, gives also rise to new languages, Creole languages, Pidgin languages. Okay, and in that specific case, the model, as we will see, predicts that you don't need any more language control. Okay, to best exemplify the model is actually this experiment which we did in Switzerland, in Geneva, with students from the University of Geneva who were following the course for becoming simultaneous interpreters. So they were very high proficient. Their native language was all German, and they were being trained on becoming German-French simultaneous interpreters. And the experiment per se is a very simple experiment. It's just a naming experiment. So under the scanner, you have to name the pictures they see. After the picture, in one condition, which we call selection in L1, so a monolingual context, after the picture, there would be a cue that indicates whether to generate a noun or a verb based on the picture they see. So in one case, could be car, vehicle, and so on, or it could be, if it's a verb, it would be driving, parking, or whatever, okay? And then there was, with the same subjects, with the same stimuli, there was another condition in which they had to generate only nouns, but based on the cue, either in German or in French. And we analyzed, the pictures you see there, we analyzed only nouns, German nouns here, okay? And German nouns on this. Okay, so we have the same subjects, same language, same pictures, but if you see, the brain activity is totally different. Okay, and this is based on the context in which they are. This is a purely bilingual context and a purely monolingual context. And what you see is, in the bilingual context, you have activated both codeates, you have much more brain activity in the prefrontal cortex, outside the language area. Okay, this is already outside of the language area. And you have more activity deep inside the brain in the anterior cingulate cortex. So this is a control network, because you are placed in a bilingual context where probably you have to inhibit one language to talk in order to talk the other language.
Can I just
Yes.
So would you perhaps like to use this? It's the first thing. And the second thing is I got some feedback from the many people online, and I just noticed that the camera points to that corner.
To that corner.
So if you're able to move the slides with this, if you stand over there, then people at home can actually see.
So
Yes. Can you move the slides with the thing?
Yes.
Does it work? So I think I'll ask, but I think I saw a screenshot. This is where the camera seems to be.
Perfect.
Thank
Don't worry. So the differences we see here are the codeates, so as said, the prefrontal cortex, the ACC. And you probably heard a lot about the bilingualism, as we will see later, can give you some advantages for aging. Okay, I'm not going to talk about bilingual advantage, but we should call it actually bilingual effect and not advantage, because advantage makes a lot of people angry. Okay, and yes, and as I mentioned always, I don't care if someone is 16 milliseconds faster on pressing a button on a flanker task than someone else. Okay, it has no real life repercussions for our everyday life. Okay? But if, as we have seen, as many others have reported, if you continuously activate those brain areas, okay, the repercussion on the brain is that you increase gray matter in those structures. And one day when we age, we may need this, what we call neuroreserve, in order to resist cognitive decline. Okay? So this would be a bilingual effect. Coming back to the model, as I mentioned to you before, we have a single language context, a multi-language context, and a dense code switching context. Okay, here you see the various components of domain general executive control. Okay, in a single language condition, you have interference control and goal maintenance, but all those components in green are actually not necessary, which become necessary if you are in a multilingual, multi-language context. Okay, and if you see the dense code switching, cognitive control is not anymore necessary, except opportunistic planning, because even if you mix two languages, it has to be planned somehow. We did some experiments in listening to stories that could switch from one language to the other. Okay, and in some occasions, the switches would respect the values of grammatical rules, of constituents of the sentence, and other switches that would not respect them. Okay, but at the brain perceives it almost as the same. In a purely multiple language intellectual context, or the real bilingual context, you have all the anterior part of the control network. Okay, you have the basal ganglia, the anterior cingulate cortex, which is the area with which we monitor our actions. Okay, and you have both inferior frontal cortices. Okay, which I now know that the left helps us to select items, and the right counterpart would help to inhibit wrong responses. Okay, I haven't placed here the single language context because it's the same at the moment. And we know how we speak as the neural basis of monolingualism. And in the dense code switching context, it is postulated that there is a connection between the cerebellum, especially the right cerebellum, and the left inferior frontal cortex to coordinate language output. This is a study we have done in India on Hindi-English bilinguals who came from a context where both languages are frequently and constantly spoken. And it's a diffusion imaging, diffusion cancer imaging study, DTI, which shows you especially the connections through white matter. So what you see here is increases in white matter, okay, bilinguals more than monolinguals, okay. And if you just watch these connections, it's almost the same. I made this slide a year ago, okay, with ChatGPT. I was asking ChatGPT, tell me about the future of neuroscientific studies in bilingualism. Okay. And well, ChatGPT was very disruptive. With some of the things I agree with some not. So advanced brain imaging, okay, we will see it later, but neuroplasticity and language learning, I think we pretty much know what it is. Cognitive benefits of bilingualism, I just told you, if it's for demonstrating any cognitive advantage, I wouldn't spend any more grants on doing this. There are much more fancier things to do. Genetic and environmental factors is very, very important. Neuroprotective effects, we're going to talk about this, okay? Technological interventions. This is a hot topic because this is where we can probably in the future combine artificial intelligence with the learning programs and so on. Educational policies and brain development, ethical and social implications, neurolinguistic programming. Well, we're not into this. So before I was using ChatGPT for making this slide, I had my own slide, which was actually this. And so it's a little bit different of what a human researcher thinks about the future and what an artificial intelligence robot thinks about the future. So, and this is actually what I'm going to talk about today, about the foreign language effect. Okay, it's I would say it's a relative still new field. Also, the first studies are already dated 10 years ago, 12 years ago, but it has a huge potential. Bilingualism and healthy aging, cognitive decline, a very, very fruitful field, and we haven't studied, I would say, even less than 10% of what we can do actually in the future. And it has very important repercussions on our health systems. Networks neuroscience, the Consortium, which has been totally neglected. I will show you some this one experiment. The Consortium was on board when Obama became president. Okay, the US really decided to make the decade of the brain Consortium. Okay, something about modeling, and another big chapter I think is individual differences, which really influence our everyday performance. Okay. And if you combine individual differences with bilingualism, that is very interesting. So to start, I start with the foreign language effect. Okay, probably you all know what the foreign language effect is. Okay, that we can make that we make this different decisions based on whether we use our native language or a second or third language. Okay. Decision making in a second language may result in choices that are systematically different from those that would be made in L1. Right? More analytical and less emotionally driven decisions. Okay. Since we are in the UK, when the first results of this field came out, and I remember a nice study by Albert Costa, even the European Parliament by then, it was 10 years ago, 12 years ago, would discuss this. Okay. And that were and if I remember well, it was the years of Brexit, okay? And all other European countries would just make this joke that the only Europeans that don't talk a second language when they are in Brussels are the British. So they make worse decisions than who is using a foreign language for decision making. But we see it also in the moral domain, bilinguals are less likely to act deontologically, opting for the greater good, utilitarian decisions. Okay. There are some hypotheses underlying the foreign language effect. One is the cognitive enhancement hypothesis. For which states that for a second language, we would increasingly rely on deliberative processes. The second hypothesis is the reduced emotionality hypothesis. Since we don't, since our decisions or second language are not based on feeling emotions, they are fundamentally different. And most importantly, reduced access to norm hypothesis. Okay, less automatic access to normative knowledge because usually we learn our second language a little bit later in life, and we haven't made those norm experiences with that language. Okay, but most importantly, we are now in 2025. Okay, it's not anymore bilinguals and monolinguals. Bilingualism has always to be characterized. Okay, it's not the same for all bilinguals. Okay, each bilingual is different. Okay, and we have always to take this into account. Age, as you see here, age of acquisition may matter. Proficiency can matter as an exposure too. For some of this, for some aspects of foreign language, affect increasing proficiency may overcome differences. Okay. I can skip this one. Okay. Another criticism I could put into our field in neurolinguistics and psycholinguistics is that 90%, 95% of our studies are based on single word paradigms. Okay? And usually many linguists, I don't know, Patrick, if you agree, always say single word is not language. Okay. And this is a big problem for our studies. Many of our studies, I would say, are not reproducible in real life. So we need much more experimental conditions that reflect how we behave in real life. Okay. So, and the only thing to do is actually using like naturalistic viewing paradigms. Okay. And this is the study which I'm going to present to you today. It was the part of a PhD thesis of Camilla Bellini, who just discussed her thesis 2 weeks ago. Federico was also there at the dinner. And it's about watching movies. Okay? Nowadays, with HBO, Amazon Prime, Netflix, and so on, who is not a native English speaker, we have the possibility to watch the movies in English, original language, and not that. Okay. When I ask my students who watches translated movies or original movies, 80% will watch them translated. Okay. Only few will watch them in the original. So in this experiment, we decided to in the scanner to because our subjects to watch movies that were emotionally loaded. Some of them were sad, some were funny, some were neutral. Some of them were dubbed, some of them were in original language, and they wanted to see the difference. Okay, and these were our working hypotheses. Emotional movies in L1 versus L2 should elicit enhanced brain activations within the conceptualization network. Okay? Emotional movies in L1 versus L2. Only L1 should evoke a greater involvement of the amygdala, which is the neural structure for emotions. Okay, especially for when we are happy. Okay, and the other thing was our hypothesis. Once proficiency is high enough, probably this difference will disappear. Making an experiment like this, of course, naturalistic experiments is more effortful, more time-consuming. Okay? Imagine, I'll explain it. These are our subjects, okay, 52 Italian English bilinguals. We have characterized them as best as we can. We are not anymore, since years, not anymore looking for a homogeneous group. We're always looking for this homogeneous group where we can get the proficiency, the variability in proficiency to correlate it to brain activity. The thing I want to talk about is actually this. It took us more than 6 months to prepare the experiment. okay? Because we need a lot of video clips, okay, dubbed in each language. We have to cut them, okay, we have to divide them, and then first thing we do is a stimuli norming, in which we took 33 native speakers just to see if those movie clips, 1 minute long, elicit the emotion we were looking for, okay? And at the end, we ended up with 31 1-minute video clips in L1 and 36 in L2. And they were divided by, as mentioned before, in funny set and usual videos. You see the experiment, okay? And these are the first results, okay? Whole brain analysis, okay? You see the entirety of the left temporal lobe plus valgus area activated. We haven't seen this activation, this type of activation, since 1999, okay? Among the first three neuroimaging studies that were published in our field by Jacques Miller, Daniela Ferrari, Stanislav Dehaene, they were about comprehension of stories, right? And they all showed, it's almost now 25 years ago, that L1 usually activates much more, okay, than L2, which is the other way around that I explained to you before, that usually a second language activates much more because you usually speak it in a less proficient manner, okay? But always keep in mind, production is different than comprehension, okay? In those early studies, which used a natural paradigm, listening to stories, okay, the authors will always say, we have big activity, especially in this network, because it's a semantic network, okay, for the language which you better understand. So it makes sense. But then, I don't know why, from, I said, 1999 till up to now, no one uses those paradigms like natural paradigms. And if we compare funny movie clips in L1 to funny movie clips in L2, we have specific activity on the right hemisphere, which is very interesting, but still in the temporal lobes. Okay, the contrast SAD versus SAD, L1 versus L2, yielded no activity. Then we did a specific region of interest analysis on the amygdala. Okay, and it was significant only for overall for emotional movie clips in L1 and compared to L2. But there was something very interesting. If we correlate their language proficiency to the amygdala activity, we have this graph that with increasing proficiency, okay, subjects would activate the amygdala like it was would be for the native language. And this is what I meant before, that in some cases, probably language proficiency can overcome the so-called foreign language effect. Okay? So in conclusion, emotional video clips in L1 versus L2, we have enhanced brain activity along the temporal lobes, okay? So the conceptualization network, greater language dependent access to conceptual knowledge to construct emotions in the native language. We have for L1 specific and greater involvement of the amygdala, easier and faster activation of affective properties for L1 versus L2 concepts. But as mentioned before, language proficiency can overcome this. The aging brain. Aging is really a beast. We cannot stop it, okay? Even as hard as we try, we cannot stop it. So it's inevitable. The only thing we can do is we can try to postpone as much as possible cognitive decline. Okay, and there are many individual factors as we will see. So you see here the brain of a 28-year-old male and 88-year-old. What happens? You see here that there's a sort of shrinkage, especially in the prefrontal cortex as compared to a young person and in the temporal bilinguals is that these are usually the first signs of brain atrophy. Brain atrophy has a different trajectory when it comes to gray or white matter. Okay, for gray matter, you see that it goes, a linear way slowly down, while for white matter, it has this curve. Okay, and if you calculate the ratio, it looks like gray matter would increase, but it's not a fact. It's a ratio. But the fact is that white matter decline is faster than gray matter decline. In other words, white matter are our fibers. So aging leads to a disconnection syndrome. Right? You still have probably your neurons, but they're not anymore connected. So whatever intervention we have to seek for our elderly individuals is to better connect their brain. And this is the reason why my colleagues always say it's good to do crosswords, Sudoku, and all these things because they connect brain areas very well. I'm going to show you some very fast some studies we have done, and many others have done too. So, but since you invited me, I'm showing you my studies. This is, for instance, a comparison between bilinguals from Hong Kong and bilinguals from monolinguals from Milan. They were all tested, same social status, same age, and so on. But aging is slower. Okay, specifically talking about this brain area in the temporal fold in bilinguals as compared to monolinguals. Okay, and specifically in Hong Kong, we were then seeking what makes the difference. Why is it this area? Okay, the temporal pole, as mentioned before, is one of the first areas that goes into physiological atrophy. Okay, what is the first symptom of aging? If you take, for example, your grandparents. Do they struggle with something? Memory is something?
Sleeping.
Sleeping is one of them.
I don't know if it's a blessing or not, but you tend to sleep.
No. The sleeping is not so difficult. There are some pills you can give them to sleep. Okay?
Yeah.
But what I'm looking for is not so easy to resolve. It's word finding difficulties. Okay, so they struggle to find words. They may find them, but maybe it takes 2 or 3 seconds and so on. Okay, and one of the most important areas in naming word finding is actually the left temporal pole. Okay, so it's not the sleeping area.
No, it's not. Is it okay to ask?
You can. I like it. Yes.
Okay. Talking about grandparents or parents, coming from the culture that I come from, I had grandparents who all passed away, but they would, up until the moment they passed away, they would continue to recite the Quran, right? But I guess that's rote learning and has nothing to do with the type of.
Would they recite the Quran in Arabic, not? Or
Yeah, of course, in the original Arabic, yeah. But that they wouldn't know it, they don't know it as a language, they just know it,
Yeah.
the sound, they wouldn't be able to read it or like tell you what it meant. It's just memorizing it as you would memorize the form.
Yeah.
So,
I mean, the same thing we observe, especially in southern Italy, with the elderly ladies who go each day to church.
yeah,
Okay, and they easily come to ages up to 100 years.
Yeah.
And you want to just, wow, how is it possible? It's a good exercise.
Yeah.
In this case, it actually, okay, I told you that this area is important for word finding, and it's the first area that goes into physiological atrophy. Okay, and that bilinguals have some protection in that area. Okay, it goes less into atrophy. In Hong Kong, actually, with the group we had, we tried to correlate some of their demographic variables to this area to see what makes the difference, what protects them, what of the things they do in their everyday life protects them. It was not the cognitive global evaluation, it was not exposure to language, it was not age of acquisition, it was not their socioeconomic status, it was naming. Okay, the better they were on naming, the more neuroprotection they have in this area. But then we separated the naming task into L1 naming and L2 naming. L1 naming had no effect, no neuroprotection. So only the performance on second language naming predicted this effect in this area. Okay. There are many other studies. I mentioned to some PhD students before, the studies I've done in Guangzhou and in Hong Kong, which is Mandarin, Cantonese, bilinguals, and so on. If I summarize, we usually see for many areas greater gray matter density for bilinguals as compared to monolinguals. But again, it's not for all bilinguals. You have to have certain characteristics. You have to be still exposed to your second language. You have to be highly proficient, and so on. Okay, it's not sufficient to be bilingual. Okay? This was actually the first study published in this field in 2007 by the group of Alan Bialystok, who did a study, a retrospective study. They went to 2 or 3 hospitals in Toronto. They got all the CT scans from Alzheimer's patients, and then they divided them into 2 groups, monolinguals and bilinguals. Okay, and they tried also to be as homogeneous as possible, like cognitive testing should be always the same level and so on. And then they got to the images, and what they find, it was really astonishing. They demonstrated that despite the same age, right, like 74, I don't remember anymore the exact minimum age, and with the same cognitive testing, bilinguals would have much more brain damage reported on CT scan. Okay. You're shocked, but this is something positive. It's positive. It means that with less brain, they have the same cognitive performance. So they can overcome brain damage better than monolinguals. Okay, and this is what we call neural compensation. Okay, the increase of white matter or gray matter, we call it neural reserve. Okay, Rico is an expert in that. Wins is another one who studied this in detail. But there's also neural compensation. Okay? Once atrophy or brain damage sets in, some people are able to overcome this and they work normally. Some are not. Okay, and bilingualism is a good factor. Another way of showing neural compensation is PET scanning. Okay? PET scanning, PET stands for positron emission tomography. It uses a radioactively marked isotope, which is injected in the vein, and it goes to the brain, and it reports exactly where metabolism is present in the brain or not. Okay, so this is the dots, the colored dots. It's not brain activity. These are areas that are not working anymore. Hypometabolism. Okay, it's a tool we usually use for the diagnosis of cognitive decline, Alzheimer, frontotemporal dementia. They all have to do PET scanning. In this study, we compared PET scans from Milano, monolinguals, to Bolzano, which is in northern Italy, which is the bilingual region of Italy, in which they speak German as native language and Italian as a second language. And again, here, bilinguals have much more areas that are not working. They're working less. There's hypometabolism. Okay, and in this study, our inclusion criteria were different from the study of Alan Bialystok. The only criteria was they must all have a diagnosis of Alzheimer's dementia not older than 2 years. Okay. So the interesting thing is, apart from this feature, that our bilingual subjects were, in average, 4 to 5 years older than the monolingual subjects. And at least on 50% of their standard neuropsychological assessment, they were performing even better than monolinguals, especially on some memory tasks, like visual spatial memory, fluency, and many other tasks. Okay, and this 4 to 5 years actually confirms the many other studies epidemiological studies that have been carried out in different places all over the world, starting from Toronto to India, Luxembourg, Belgium, Switzerland. There are many studies on patients reporting always this time span, 4 to 5 years, delay of the onset of cognitive decline. Okay, so this is something very, very important because the delay of onset 4 or 5 years makes our governments save billions of them, okay? Billions. Because taking care of a population that increasingly becomes demented is really very, very costly. Okay. Some researchers in this field actually say that the real pandemic of our century is dementia. Okay, but there will be probably 150 million people with dementia after 2050. Okay, just to explain, so the lifelong usage of 2 or more languages ideally would enhance executive control, because bilinguals have to use this language control network, which is part of the more domain general executive control network. And it, on the one hand, it induces neurostructural changes, so you increase gray or white matter in some areas, and on the other hand, neurofunctional changes, brain connectivity. Okay, so this serves as a neural reserve, and on the other way around, as a neural compensation. What do we still miss for the future? We don't have longitudinal studies, not yet. Some centers are working on it, but we don't have them yet. And another very important point is we need comparative studies. What do I mean by comparative studies? There are also other factors that may increase cognitive reserve, physical activity, diet, or social activity, and so on. And like in the medical field, you usually do, you need to have studies in which you compare the effects of all of them together in huge populations. We don't know this, the effects of language distance. Okay, and the background idea of this is that usually 2 languages that are linguistically close are more difficult to keep separate, okay, as 2 languages that are linguistically far away. And there may be also an effect on neural and cognitive reserve. Maybe we see it more for languages that are linguistically close than for languages that are linguistically far away. And if it is so, like for aging populations, then one may think even what will be actually recommend to our populations to not lose the use of the local dialect. Because there are also 2 studies that show beneficial effects in aging for speakers of dialects. The first study that comes to my mind is from a group from Holland. They use Frisian and Dutch, and show that in the aging population who still speaks Frisian has a small effect. A very, very important part of what we do is actually this, promotion of our findings. Okay, I think by now, in the field of bilingualism, in linguistics and psychology, everyone knows of these findings. But if you move to neurology or medicine, they don't know nothing about this. Okay, so, and which is bad, because it's them in neurology and medicine who recommend then potential future therapies to people with cognitive decline. Another point is neurocognitive models. Okay, we still need much more models, or the update of models, and I include myself. This is a beautiful slide which Jason, Federico, Vince, and Thomas, and myself, and Janina also the paper have done, and it actually compares 4 different models that exist, okay, and that could explain neural reserve and neural compensation. Okay, I recommend to you PhD students read all 4 papers. Okay, each model is different, specific, but for your culture, it's good to know all of them. Individual differences. Sleep quality is an example. This is just a paper that came out recently, in which we make an opinion about about the interaction of sleep, bilingualism, and executive functions. We all know that just we're talking about sleep, bad sleep, whatever. Bad sleep has a negative impact on our executive function and on many other cognitive functions. So the idea was, okay, if bad sleep quality has this effect, may bilingualism overcome this? Okay, so in this opinion paper, we actually made our reasons, but now we are bringing out the first experimental papers. This is a paper from Lilia Telecina, Federico, and other of our co-authors, with the finding that the degree of bilingualism may compensate for detrimental effects of poor sleep quality upon executive functions. Okay, no such second language effects were present for those reporting good sleep quality. And in the paper, we had two different experiments. One was on with two different groups with two different questionnaires actually, and we further corroborated for insomnia-related symptoms, okay, which are known to deplete cognitive reserve. If you continuously have bad sleep, it's actually more likely that you get dementia earlier. Okay, so sleep quality matters. But I'm just using sleep as an example. There are many other individual differences between us, okay, that should be studied together with bilingualism, and we should interpret their effects on brain and behavior for the senior citizens in order to arrive to healthy cognitive aging, and for young adult citizens, some way to have a better cognitive performance or better decision making. Okay, individual factors, there are plenty of them. Okay, now I'm making just a very easy example. Okay, we are all used to do or behavioral studies. Okay, on the laptop, EEG studies. Okay, do you actually ask your subjects, have you slept well yesterday? They never do. We all know that if you haven't slept well, probably the experiment is not the same as you would do if you have a good sleep. Okay? So it's important that we bring these individual factors also into our field. Network neuroscience, connectomics, which I was mentioning before. We had the last decade was the decade of the brain connectome. What is connectomics? It's an experimental framework to investigate brain structure and functional organization. It conceptualizes the brain as a complex network of nodes, okay, areas, and edges their connections. Okay, it uses a tool, methods of network science and graph theory to define the principles of its organization. It allows one to quantify whether and to what extent internal and external factors like brain pathology or influence of something I newly learned influence the topological properties of the brain, connectome as a complex system. Okay, and it's a pity that there is nothing in the field of bilingualism, despite Ping Li and Angela Grant already years ago would say it would be really, really important for bilingualism to have the bilingual connectome. There's only one study we have done together with Jason. We published it 3 years ago. It was a long, huge study and part of the PhD of Davide Fedeli. So the aim was to describe, because you have to start with something, how the brain structural connectivity is shaped by distinct components of the bilingual experience, like age of acquisition, language proficiency, and exposure. We had 77 Italian English bilinguals. Okay, we studied them, I hope, very thoroughly. And this is actually how you create the connectome. Okay, you have to acquire different brain imaging sequences. We need diffusion imaging, we need structural imaging, then we need brain parcellation, and then everything comes in this NBS connectome tool, which the end effect would be from brain structure. These are white matter connections we can this. Okay, so we can calculate for each node the influence of an external factor in this case. So let's start. Exposure, the effect of exposure on the brain connector. Okay. There were actually two sub-networks. In this one, you have a more posterior parietal, occipital, and temporal network. Okay, with each connection. With the central row of the superior temporal sulcus. What are the roles of this network? Cognition, maintenance, and retrieval of lexicosemantic information. Okay? And exposure is very important on this retrieval of lexicosemantic information. During lunch, I was talking with two PhD students from Guangdong province about an experiment we actually made there. We took university staff from the University of Guangzhou. The university staff was local, and in Guangzhou you speak Cantonese as your first language and not Mandarin. Okay? In August they have 1 month of holiday. During work they would speak usually Mandarin, but during holidays they go back to their villages and speak only Cantonese. We scanned their brain before going to holidays, and on the first day they came back from the holidays. And during the experiment they had to tell us what they have done the day before for lunch, for dinner, and so on. So it was connected to each other, I would say. We did it for L1 and L2. Before they went for holidays, brain activity for different language areas and control areas was almost the same. Right? But just 1 month being home and talking mostly Cantonese, native language, made a huge impact on brain activity. Like areas like Broca's area and some control areas would be much more activated when the subject was speaking Mandarin. Okay, to all of you, I mean, this is something you can probably feel yourself. If you're not a native English speaker, okay, and you move because of academia and your work for say 6 months or 1 year to the US, to England, okay, then you go home to your native country. The first 2-3 days, you are slower on generating your native language words. It is, and this is the effect of exposure. The second sub-network on exposure is a poorly controlled network. Okay. Central row, inferior frontal gyrus, connected with the anterior cingulate cortex and the prefrontal cortex. It is involved in speech production and articulation, of course, but mostly language control. Okay. When it comes to the effect of proficiency, it's again a nice network with ACC, some prefrontal areas, especially parietal areas, and temporal lobe areas. And this network is involved in vocabulary acquisition and second language learning. There's a very nice study by Jenny Crinion from UCL, in which she showed that specifically this area here, the larger your lexicon is, so the larger your vocabulary is, the more gray matter you have in this area, in this parietal area. So we have strong evidence when we claim that it's involved in vocabulary acquisition and so on. This is fun. Effects of second language, age of acquisition, non-significant. Right? But if we calculate the interaction between age of acquisition and exposure, we have a very significant network. Again, this is a network which is based on language control and language production. Okay, importantly, this network is more segregated in late bilinguals. Okay, they rely more on this network and not on other structures to face high levels of second language exposure. Okay. Conclusions. Second language exposure, 2 subnetworks associated with production and comprehension, and control must say, second language proficiency, a network related to learning and language selection. the interaction of second language, age of acquisition, and exposure, and interhemispheric network related to cognitive control. Okay, and of course, it's just an invitation for who is interested to invest much more in your brain content. It's really a very, very nice tool to explain things. And the last part of my talk is actually about this. It's just 1 minute, and we have to combine all these evidences, cognitive modeling, okay, which we are a little bit behind. There are only a few models for bilingual language production. For comprehension, there's actually nothing, I guess, okay? Together with this data in order to arrive here, okay? I mean, artificial intelligence is useful, okay? On the one hand, it helps us. On the other hand, it will lead us probably to artificial dementia, okay? Because if we don't think anymore, but someone else thinks for us, then whatever I was telling you here for protecting our brain will not happen at all, okay? But it's inevitable, as I think, okay? Last thing, a big thank you to all people who contributed to all this papers and nice work. I have finished.
So I think we have around 10-15 minutes for questions. Because we have to go until 3:30. Jubin, maybe we start off. So we have also a lot of people at home, but I suggest we start off with the questions here in the audience, and I'll have a look at the chat to coordinate. So maybe you start off here with you, and I'll keep an eye on the chat on this.
This is a really interesting talk, and thank you very much for that. Especially for me, because I don't have like that much experience in neurolinguistics, but I do heritage language bilingualism. So I was interested in the antepenultimate, not the one before.